Are wind turbines, are the rotor plates of wind turbines. Further applications are pipelines, where I have a lot of screws, and these screws have to be monitored regularly to care for the integrity of the whole pipeline. Other application examples are railway trains, so the wheels of railway trains, or any kind of big vehicles where I have screws on critical points which are monitored from time to time.
So Peter, the keywords are basically disaster prevention and risk management, then of course predictive maintenance, documentation for reliability, and are those the pains? Have I forgotten anything else?
It's mainly maintenance cost. It's maintenance cost and inspection time. So with this system I can reduce the maintenance cost seriously, because I do not have to be on site to monitor the screws. I can do it from the remote. Potentially I can do it from any point in the world.
As we know, data rules, and of course if you collect the data you can also even put up models and you can see behaviors either of your construction. You can even put it on a time schedule that you can say after 5 years I can see in this and this and this positions I have material which basically loses their original setup, and you can basically then in preventation or in new build-ups consider the learned or the lessons learned from the past. I think it's awesome. But one of the key points is, I mean, sensing is crucial and it's not easy, but what's really was hitting me was that this thing is an independent standalone system.
Yes, it's completely standalone and it's completely self-powered and maintenance-free. So we take the energy from a whole sensor and for the wireless connectivity either from solar cells or from thermoelectric generators. So I do not have to recharge or replace battery during operation. Potentially this system can run for 20 years.
This is exactly the point, and I believe the next step of endpoints, because a lot of end users, the first question they have is, how about battery lifetime? This is one of the first questions you will get, and of course there's a pain behind it. So they don't want to get out, especially in the areas. Worst case, you have to climb a wind park, you have to go really up there, or you are in a remote area in Norway in the winter time. It's no fun to basically really check the bridges. So far, this is one of the first products, maybe there are some out there, which are totally independent, so it's basically install and forget.
Exactly, this is the idea behind it. Install and forget, no maintenance cost, no any care you have to take off for the later reuse.
So we know it's a new invention, so how available is it to the end user?
So presently we are producing evaluation kits for a certain screw geometry, so we're provided for M80s, M20 screws, M36 screws, and furthermore potentially for M48 screws. These evaluation kits are available for any kind of test installation until the end of the year, and at the end of next year we are planning to have first products on the market or first production run of the system.
So again, this is not fiction, this is reality, it's a real product. You can really use it for POCs. Peter, you already told us in what dimensions, in what volumes we can get it. Of course, you can ramp it up, we can scale it up. In the very end, we have to industrialize it with a producer, right? That's the target and the goal. So we have talked a little bit about advantages. What unique selling points does your product include?
Actually, the unique selling point is that it's completely self-powered, it's maintenance-free, and it's completely retrofittable. The good thing with this system, comparable to any competitor in the world, is we do not have to change the screw. We can work with any screw size, or we can adapt it, retrofit it to already existing screw connections. So there is no change in the screw.
Wow, this is almost a customer dream. Okay, you don't have to change anything, you just put it on top. But I mean, we understand the concept of a screw. We understand, of course, your mioty endpoint. We understand the energy, how the energy comes to your system. But the basic question is, what components does your system consist? So, out of what?
So actually, the first component is a thin film sensor. So it is the sensing component which does a preload measurement on the washer. So we have 3 preload sensors on that washer, so that we're also able to measure any inclination of the screw connection. In addition, of course, we have a mioty wireless module for sending the data out, and we have a power supply which uses either a small solar cell on the head of the electronics, or it uses a thermoelectric generators. So these are the 3 main components, and of course in the back end we have a mioty base station to get the data from all the screws.
Well, Peter, it's almost a rhetorical question, and I'm going to place it. I would say, okay, why mioty, and which advantages does mioty offer? So one can say, well, he's a Fraunhofer guy, he's almost obligated to use mioty, but they are not living in the real Fraunhofer world. Because if you try to convince a scientist, a researcher of a thing he doesn't approve, you will have a hard time to make him to use it. Because what you're looking for is a solution which is reliable and really makes sense for the industry. It's not for research purposes only, this is the beginning. But what you are striving for and Fraunhofer is striving for is you want to make innovative products and you want to release them in the real world. Real end user, massive scalability, even better. So what advantages does mioty offer for your solution?
Yeah, so that's very easy. So mioty is very energy efficient. And as I told you, this system is completely self-powered, so we're relying on energy harvesting. So the energy consumption is a key performance indicator of that system. We are aiming for the lowest power consumption, because only with a low power consumption we are really able to rely completely on energy harvesting. Otherwise we have to recharge batteries or change batteries, and that's actually not accepted in applications like wind turbines. Nobody is willing to change batteries in wind turbines or on trains from railway. The other big advantage of mioty is very robust. These screws are working in environments with a lot of metallic objects. So I have a lot of reflections, and these reflections might interfere or disturb my signal. And due to the telegram splitting in mioty, we can work with these reflections. We are extremely robust in any kind of industrial application, and that's a big point. And the third point, which became obvious in the last couple of years, is that I can use off-the-shelf wireless modules with mioty. So for example, if TI is not able to provide any wireless chips, I can change to ST, I can change to Scilabs. I'm not relying on a single semiconductor company. And that's presently, during the Corona crisis, a big advantage, because the chips are very rare.
If you come to the point that you have to buy a washing machine just to get one chip and throw the rest away, that shows the pain of the industry, and that's the reason why mioty, being a software, and you can really have a liberty to choose your producer, that's awesome. And looking to that 2 years ago, it wouldn't have been really such a pressing drama, but this is really what the customer wants. They don't want to be handcuffed to one standard, they want to be able to have multiple suppliers, and so you're dead on. So you all thrilled us, we are all excited and hyped. When can we get this technology? And maybe we together can announce an invitation to sensor manufacturers. So if somebody's out there who is able to have a bigger scalability, can support this wonderful solution, you would welcome them with open arms, right? So guys, what are you waiting for? It's a wonderful solution. Now is the time to call Peter up or his staff. So anything else you want to get as a food for thought to the community, or you want to add? No? Well, then I tell you something, I will not send you away with a goodbye. If you have another innovation, whether you have mioty or not, we want to have you here, and we want to hear all about it. Well, good luck for you, for your product, and thanks for taking the time to be here. It was fun as always.
Thank you.
Thank you, Peter.
Thank you. Thanks a lot.